Obtain the Fourier series representation for the signal and sketch phase spectra and magnitude spectra of x of t is equal to sine 2 pi t plus cos 3 pi t. Now consider this as a omega 1 and this as a W2. Now there is a formula, and that is T1 is equal to 2 pi upon W1. So it is 2 pi divided by, this is 2 pi. So both get cancelled. So answer is 1 here. So T2 is equal to 2 pi upon W2. So 2 pi divided by 3 pi. Pi and pi get cancelled. So the answer is 2 by 3. Now the next step is T1 divided by T2. Divide these two. So 1 divided by 2 upon 3. So 3 goes up. Now this is what? It is a rational number. Whenever it is a rational number, then this given x of t is periodic. Fine. Now cross multiply this. So 2 into T1. Now next this will be 3 into T2. Assume that T means what? It is fundamental period. Okay. Now T is equal to 2T1. Now what is T1 value? 2 into 1 is 2. Again T is equal to 2, not 2, it is 3 T2. 3 into, what is T2 value? It is 2 by 3. Again the answer is 2. It means that fundamental period T value is 2. However, now next omega or W naught is equal to 2 pi upon T. Here I have taken T is equal to 2 pi upon W. Here I have taken W naught is equal to 2 pi upon T. This is called as fundamental frequency. I'll write here. It is a frequency. 2 pi upon, what is the T value here? It is 2. 2 and 2 get cancelled. So the answer is 2. Now there is a formula of a Fourier series. X of t is equal to summation of k is equal to minus infinity to infinity x of k e raised to j k omega naught t. Now what is the value of this? It is 2. Substitute here. Summation of k is equal to minus infinity to infinity x of k e raised to j k. In place of this, write 2t over, I'm sorry, so 2 and 2 get cancelled, pi is remaining. So omega naught is equal to pi. Here in place of omega naught I have written pi. Fine. Now next, sine. For sine there is a formula, e raised to j, here there is a 2 pi, so I'll write here 2 pi t minus e raised to minus j 2 pi t divided by 2j. Let me tell you, for sine this is the formula. For cos it is e raised to j and there is a 3 pi here. So it is 3 pi t. There is a minus for sine. For cos it is plus. E raised to minus j 3 pi t divided by 2 for cos. For sine it is 2j. Okay, you can see here k, j pi t, j pi t. So k value will become 2 from here, minus 2 from here, 3 from here, and here it is minus 3. Okay, these are the values. Here k value, first I have taken 2. So x of 2. Okay, so e raised to jk. So here 2 is there. So what is the coefficient? You can see 1 upon 2j. Okay, next I have taken k value as a minus 2. So minus 2 is here. Again, what is the coefficient? It is minus 1 upon 2j. Okay, here k value I have taken 3. So from here 3 means what will be the coefficient? It is 1 upon 2. Okay, now k value I have taken minus 3. So minus 3 is here. So what will be the coefficient? 1 upon 2. You can tell these are real part and these two are imaginary part. This is very useful while drawing the phase spectra and magnitude spectra. Now sketch phase spectra and magnitude spectra. So I have written here magnitude and here a phase. Okay, so modulus of x of k will always be positive. How? X of 2, what is the value here? It is 1 upon 2j. So the answer will come in positive. X of minus 2, you have minus 1 upon 2j. Even though it is minus, you have to write a positive. So that is the actual meaning of a positive. And you should not write this j. Remember that. Now x of minus 3 is 1 by 2. So modulus of 1 by 2 is again 1 by 2. X of 3 is 1 by 2. So you need to write 1 by 2. Fine. In the phase spectra, the formula is tan inverse of b of k divided by a of k. You have studied in the lower classes complex numbers a plus ib form. A means real part and b is an imaginary part. Fine. Now 1 upon j means minus j. So here 1 upon 2j is there. So this will become minus j by 2. You can see here there is no real part. Here minus 1 upon j will become j upon 2. Here also no real part. And you can see here no imaginary part. You don't have imaginary part here. Are you understanding? Now tan inverse of, this is imaginary part and this is real. Okay. Now tan inverse of b by a. So imaginary part is minus 1 upon 2 and the real part you don't have. So it is 0. So this minus comes out. Tan inverse of infinity. Tan inverse of infinity is pi by 2. Since there is a minus here, I'll write minus. Now again, tan inverse of minus 2. Minus 2, what is here? 1 by 2. You should not write j. But that is the imaginary part. Real part you don't have. So it is 0. So tan inverse of this is infinity. So infinity means it is pi by 2. Next, phi of 3. Tan inverse of imaginary part. You don't have imaginary part. So it is 0. A of k is what? 1 by 2. 0 upon anything is 0. So tan inverse of 0 is 0 itself. Next, tan inverse of real part is 1 by 2, imaginary part is 0. 0 divided by 1 by 2, so it is 0 because tan inverse of 0 is 0. Now let us draw the diagram. Now this is x of k modulus, and these all the values are k. Now x of 2, it means here it is 1 upon 2. So draw like this and write 1 upon 2. X of minus 2, come on the left side and write here 1 by 2. X of minus 3 is 1 by 2. Fine. X of 3 is 1 by 2. Okay. So other terms will all become 0. Now to draw the phase spectra, phi of 2 is how much? Minus pi by 2. So phi of 2, sorry, this is all positive. Okay. These are positive and these are negative. So this is minus pi by 2. So minus comes in here, and phi of minus 2 is pi by 2. So it will come pi by 2. Phi of 3 is 0. So I'll mark only this much. Phi of minus 3 is 0. So I'll mark 0. Only these two values will come. This completes your answer. I hope you understood very well.